Now we are discussing SCR triggering using UJT. We know SCR is a three-terminal device, anode, cathode and gate. We are giving some supply to the anode and cathode. Here we are giving some supply when the switch is closed. Some supply we are giving VBB to the SCR. Some supply is closed. Example, if from this side, when we are connecting a load and AC voltage. So here when we are giving some supply, or in some cases we may give this voltage. When we are giving supply anode to cathode, if we give the gate current, then only SCR will be triggered. Otherwise, we have to give the anode to cathode voltage 200 volts for the breakover. Now, this gate by using the gate terminal, we can trigger the SCR in the two ways. Either we can give the DC voltage to this gate terminal, or we can give the pulse to this gate signal. In order to turn on the SCR, we require the gate. Once the SCR is turned on, even if we remove the gate current, SCR will be in the on state only. The anode current of the SCR will be controlled by using the external load. So instead of giving direct DC to the gate, we can give the pulses. Now the question is, who will give the pulse? Then the answer is UJT. So this UJT is ready saying that I will give the pulse. This UJT will give pulse only in the negative resistance region. If we operate this UJT in negative resistance region, then this UJT will give the pulse. That pulse can be given to the gate to trigger the SCR. That is the triggering of the SCR by using the UJT. See here, we have the UJT, base 1 and base 2 and emitter terminals. We have connected the base 1 terminal to the gate of the SCR such that the trigger pulse from the UJT will trigger the SCR. Triggering means turning on SCR. Initially, we are giving DC supply. R1 is the variable resistor and C is the capacitor. The switch S is closed. By using this supply, the capacitor will charge. When the capacitor is charging until the peak voltage, remember the negative resistance region characteristics of UJT. So at what voltage UJT will turn on? Peak voltage. At what voltage UJT will turn off? Value voltage. Means turn off. Here in this region, it will work as a negative resistance region in this region. After this, in the saturation region, it will continue to increase the current. We are concentrating the voltage between value voltage and peak voltage. So once the voltage across the capacitor reaches the peak voltage, immediately UJT turns on. Because the UJT is turned on, this acts like a short circuit and the capacitor starts discharging through the resistor R3. So the same voltage will be given as a pulse to the gate of the SCR. When it is occurring, when it is reaching the peak voltage, at that time the UJT is getting turned on. At that time the capacitor is trying to discharge through the R3. At that time it will give the supply to the gate and the SCR will turn on. And the capacitor will discharge until the value voltage. After value voltage, again it is open circuited. Open circuited means again the UJT will come into existence. There is no short circuit. Now again R1 through R1 the capacitor is charging. After the peak voltage, again it will be short circuited. This process continues. Now what is the rise time of the pulse? The rise time of the pulse depends upon the R1 and C. We are not varying C, but by changing the R1, we can tell at which point we can trigger the SCR. Example, at this point, I want to trigger the SCR such that the the firing angle will be given to the gate in such a way that at this point the SCR will turn on. Now the output voltage will be, why we are not getting negative voltage? Because SCR is a unidirectional device. Why we are getting from this point only? Because we have triggered SCR at this point only. If we triggered SCR at this point, then the output voltage we get only this one. Okay. Now, as we already discussed, once the SCR is turned on, we require the external load to control the anode current. But the problem with this circuit is, we are giving DC voltage to the capacitor. Because we are giving the DC voltage to this capacitor, the gate pulses, whatever we are getting, they are not in synchronism with the input DC voltage. So we are modifying the circuit a little. So this time, I am not interested in giving the DC supply. I am giving the full wave rectified output. So this is the full wave rectified output. In this full wave rectified output, I want to remove the extra voltage. So that's why I am connecting it to GNR regulator, GNR diode. So GNR diode removes the extra voltages. So we will get the flat top voltages. This is the output from the GNR diode. Same full wave rectified output we are also giving to the SCR also. The advantage with this circuit is there is no need to give two supplies. Single full wave rectified input is sufficient both for the SCR and for the UJT. Here, the capacitor charges with the R1, and in the similar fashion UJT will produce the pulses. Now whatever the pulses number are there, these pulses, example for this cycle 1 pulse, for this cycle 1 pulse. If we are using 3 cycle here means 3 cycles means 3 pulses already generated. The pulses generated at the base 1 of the UJT, they are in synchronism with the input full wave rectified voltage. So the same thing here also we are triggering the SCR by using UJT. Previously we used the DC voltage to charge the capacitor, now we are using the full wave rectified voltage. This is the only difference.